Hello, I'm Mike River. I'm representing the Cold Jet Engineering Department here, and I'm here to show you some of the P3000s we've had. Basically, these machines are the culmination of 20 years of experience that we've learned over the years building machines. We've put a lot of advanced features into them, a lot of reliability features into them, a lot of learning over 20 years. You'll notice we have the control panels out front. There's a separate control panel for each side, 2 barrels on each side. So basically, it's effectively 2 independent machines. You can operate them, you can do maintenance on one side while you're running production on the other side. We've got a full HMI, human-machine interface, which has all the instructions, which you can use to program your chill down cycles, your strokes. You can actually get all the error messages, the warning messages come up there too, with instructions on how to properly fix these messages, these problems with troubleshooting, basic troubleshooting guides. It gives the operator on the floor some hands-on control of what he's actually doing with the machine. We've got it fully instrumented with gauges for our chamber pressure, injection pressure, vapor and liquid pressure, and our hydraulic pressures. So we can watch all that while the machine's operating. We've modularized most of the components now. For each cylinder, we have them all located on a single structure. We'll show you more of that, but it makes it a lot easier. We keep maintenance as a prime requisite on these machines because we know they're in full-time production. Downtime is serious money, so we try to make them as easy and affordable to fix as possible in a quick fashion. I also notice we have drip pans. We provide a water drip pan for the condensate that forms on top of the extrusion cylinder when it's in operation. And we have a large drip pan that catches both the hydraulic fluids and the condensate drip on the bottom because we know these things can get messy. They run 24 hours a day, and we want to make sure they don't leave a big puddle on the floor. We've also got extensive use of aerospace materials. That's not a steel. That's a very expensive material. It's the only thing we found that will withstand the high pressures, the constant force, and the low temperatures that we're encountering. We try to make these machines last. Also, we actually do a high pressure extrusion. We've got an 8-inch hydraulic cylinder, which goes into a 6-inch extrusion barrel, which gives us a great mechanical advantage. We're getting a lot more force and pressure inside that extrusion chamber than most of the competition, which gives us a lot more control over the actual density of the pellets coming out. I guess we can move around to the back side here. You can see we've got the independent hydraulic units. There's one pump for each side so that you can maintain one unit while you're working on the other one. They do have a common hydraulic reservoir tank, but they have separate oil coolers, directional valves, all the other sensors. We've also tried to, here's some of the modularization. We use the quick disconnect pins for all the electrical connections, which are very good for troubleshooting. They've got LEDs on them. They'll let you know. It's great for the troubleshooting guys. We can talk to people over the phone. They're labeled, so they can easily troubleshoot and diagnose a problem in the field without too much trouble and keep the machine up and running as fast as possible. We've got the liquid and the vapor hookup. This machine takes a 1-inch liquid line and a 3/4-inch vapor line. And basically, we're taking the one liquid line, we're splitting it off into 2 separate systems there. So it is truly 2 separate systems. We've also got a couple chamber pressure switchers here to monitor the actual chamber pressure and see what your actual flow is. You can troubleshoot some problems with your actual CO2 feed in the field if you have issues with that. So it's just another tool to use to really keep the machine up and running for you. All right, here's the business end of the Pelletizer. Now, we don't have any chutes on here. These are just the die backing blocks, but we have several options for chutes. We have the chopper motors, which will actually break the pellets up into small particles ready for blasting. And we also just have the regular dispenser chutes, just to load the ice into the boxes for shipment. Everything's quick disconnect. This is for the chopper motor. We can remove those at times, so you can change the pellet dies in literally a matter of minutes. We can do that in 5-10 minutes, put new dies on, even when the machine's completely frozen. Everything's accessible for maintenance. You can see the oil filter for the hydraulic system, the valves. We've also got a hydraulic pressure switch there. What we're doing is we're monitoring for the pressure on the retract cycle. That's one of the major causes of failures of machines when they get worn wear rings, is you get snow building up behind the piston. And previously with older machines, they would actually keep compressing it back, and we would break that piston bolt, which would leave you for a complete shutdown. Now we're monitoring that hydraulic pressure, so we actually stop the machine before something breaks. It tells you that error, gives you a way of correcting it, you thaw it out, and you're good to go. Just for fine-tuning the liquid flow for the injection cycle. Most plants do not have a consistent CO2 supply as to where we have to adjust it for periodically for different sources during the day and whatever's going on. But this gives the operator a way of doing minor adjustments. It's not a major adjustment, it's just for fine-tuning the machine in operation.